Hey guys! So we're still busy with stoichiometric calculations, and today's topic is limiting reagents. So a limiting reagent is a reagent that is completely used up in a chemical reaction. Okay, so I'll be using this simple chemical reaction to explain to you a limiting reagent. Now in this reaction, we've got my reactants A and B giving us AB. So 1A plus 1B gives us 1AB, and that is the ratio in which this reaction occurs. So as you can see, it is a balanced chemical reaction. Now, I have 1, 2, 3, 4, 5 moles of A, and each of these little balls will be representing a mole. And then I'll have 1, 2, 3, 4, 5, 6 moles of B. And each mole of A will react with 1 mole of B to give us, as we said, 1 mole of AB. So here we have 1, 2, 3, 4, 5. Right. So we get product, or 5 moles of AB with 1 mole of B remaining. And if I had more A, I would be able to create more product, but I don't, which means that A is my limiting reagent. Right, so let's say we have a different chemical reaction. Again, this is just a simplified version. But in this case, 1A reacts with 2B to give us 1AB. Right, so 1 of A is required for every 2 B's. So we have 1, 2, 3 products formed. Now I cannot continue because my B is finished. If I had more B, I would be able to create 1 more AB, but I don't, which makes it my limiting reagent. So as you can see, a limiting reagent doesn't just depend on which one is less and which one is more. It also depends on the chemical reaction, the ratio in which the reactants react, and also, obviously, the molecular mass of each reactant. Now let's look at this example. Sulfuric acid reacts with ammonia to produce the fertilizer ammonium sulfate, according to the following equation. And there they give us a beautiful balanced reaction. Now the question is, what is the maximum mass of ammonium sulfate that can be obtained from 2 kilograms of sulfuric acid and 1 kilogram of ammonia? So first of all, you'll need a balanced chemical equation. And here are my reactants, sulfuric acid and ammonia. And we want to determine which is my limiting reagent. But they give us the mass. And we can't work with mass. We first have to find out how much mole is in 2 kilograms of sulfuric acid and how much mole is in 1 kilogram of ammonia. So we start with writing out what we have and what we need. So what do we have? We have 2 kilograms of sulfuric acid. We convert that to grams. So we multiply it with 1,000, which gives us 2,000 grams. Then we have to determine our molar mass. Now, for hydrogen's molar mass is 1, and there's 2, so it's 1 times 2 plus 32 for sulfur, and then 1 oxygen is 16 grams per mole, and there are 4, so we multiply it with 4, and we add that to give us 98 grams per mole. So we want mole. There we go. So we write down what we need. And then we copy our formula from our formula sheet, which is N is equal to M over big M. And that is 2,000 grams divided by 98. We put that in our calculator, and that will give us 20,41 mole. Don't forget your unit. All right, so we know that 2 kilograms of sulfuric acid contains 20,41 mole. Now for ammonia,
we have 1 kilogram of ammonia. So when we convert it, that gives us 1,000 grams of ammonia. And then if we look at our molar mass for the ammonia molecule, 14 is my molecular mass of my nitrogen, and then obviously hydrogen has a molecular mass of 1 times 3 because there's 3 of them, which gives us a total of 17 grams per mole. And again, we are looking for how much mole is in 1 kilogram of ammonia. So we copy our formula, N is equal to M over capital M, and substitute. And then we put that into our calculator, which then gives us 58,82 mole. Right, so now we have the mole of each. Now the question is, which is my limiting reagent? So now we look at the ratio of sulfuric acid to ammonia, and that is 1 to 2. And where did we get this ratio? If we look at our chemical reaction, we see that it reacts 1 to 2. Okay, now we want to determine what is the smallest number of mole necessary in each case. So how we determine the least amount of mole in each case. So for sulfuric acid, we take the number of moles that we know is available, which is 20,41 mole, and we divide it by the ratio. For sulfuric acid, it is 1, and that obviously then gives us 20,41 mole. So in this case, the least amount necessary is 20,41 mole. For ammonia, we have 58,82 mole available, and we divide it by its stoichiometric coefficient, which is 2, and that gives us then 29,41. Now, because the minimum required mole for sulfuric acid is less than the minimum required mole for ammonia, we know that sulfuric acid is the limiting reagent. Now that we know which our limiting reagent is, we're going to continue with it. So we have 20,41 mole of sulfuric acid. Now we know, or we want to know, how much ammonium sulfate will form in grams. So our ratio is 1 to 1. So if we have 20,41 mole of sulfuric acid, how many mole of ammonium sulfate will that form? And of course, that will then be also 20,41 mole. But we want to know how much mass will 20,41 mole be. So we find our molar mass, which is 132 grams per mole, and we want to know the mass from that. We copy our formula, substitute our values, and then when we calculate it, we find 2,694,12 grams of ammonium sulfate is formed. Now do the following exercise in your workbook from your textbook, and then I'll share the corrections at the end of this video.